just talk about the simple, frequently asked question. How does carbon monoxide form in a fuel burning appliances? How does carbon monoxide created in your furnace at home?
Your furnace at home needs three things to have heat, right? It needs ignition, which is always easy. You either have it or you don't. Usually it's electric,
Spark, essentially the spark.
some sort of a spark to start the fire. But the fire also needs oxygen and it needs fuel. And the fuel that is used in furnaces is either propane or it is natural gas. And both have different properties, both have different requirements as far as how much pressure is needed to have proper combustion. A perfect fuel air mixture is known as stoichiometric, and not to get too much into the weeds, that is not how these things are designed.
Not even AI is going to be able to spell that word.
Stoichiometric, that's T O I
You
C
don't have to,
H
you
I
don't
O
have to
M E
try to
T R
spell
I C.
it.
So,
It took me a week to learn how to say that word, more or less spell
yeah,
it.
yeah, it's a hard word, but engineering students use that, learn that concept, and it's not the way furnaces or boilers are designed, as was admitted yesterday during the presentation.
Stoichiometric means the exact amount of fuel for the exact amount of oxygen.
That's
And
right, to the molecule.
if you were on a space shuttle where you had to ration your oxygen, maybe that would be the goal. But
Right.
in a
It's to the
furnace,
molecule. It's theoretical. It's difficult to maintain. And that's why they're not designed that way. These appliances are designed to be fuel lean, meaning a little too much combustion air and a little too little fuel to have a safety margin. Because if you go stoichiometric, with one molecule you're off, you're incompletely combusting your fuel. And why is that important, Gordon? Why is incomplete combustion dangerous?
well, obviously, it's all a question of degrees. The perfect teaching example of how carbon monoxide forms is you have too much gas. Usually, the amount of oxygen should be predictable. So something goes wrong with the gas supply. In the furnace we were looking at there, the gas valve stuck in the wrong location. And maybe it was the cause and maybe it was the result of. But at the end, when our clients almost died, that gas valve was stuck and there was about 40 to 50% too much gas going in there. The more common situation that we see, and we see it an awful lot in rural cases, and I'm guessing I've seen it 5 or 6 times, and two or three more that we may discover, is that there is a propane which comes in the tanks versus city people who get their gas out of the city gas lines. Propane is much more volatile, has higher octane than natural gas does. So to get the proper slightly, what was it you call slightly lean burn
Right.
that you aim for, not the stoichiometric, um, you have to reduce the amount of fuel getting to that flame by about 40%. And to do that, what they do is they put an orifice. It's just basically a little cone type fitting inside the gas line to reduce how much actual gas from the propane tube gets to into the furnace. And if they forget to put that little orifice in there, reduce orifice meaning reducing the size from this to this. If they forget to do that, you're going to get a 40% overburn and you're going to have 50,000 parts per million in your exhaust.
Most of these appliances are sold as natural gas application, meaning they won't have that orifice. So if the installer screws up, or you've got somebody that's trying to do their own installation in their home or some home that they rent to somebody else, we've run across this before, they oftentimes will not know or remember that when they're installing it in a propane application, they have to have that orifice. And then they set the fuel pressure and they're busy poisoning everybody there. So it happens a lot also. We saw it in a case involving one of those tankless heaters. It was a natural gas application that was put into a propane application without the orifice, and it was a very deadly situation.